Hey guys, Catlin here with your last page of your homework, working through the MAD problems, which we covered in class on Thursday. So here's some help on these if you need it. Looking at the first one there, Han recorded the number of pages that he read each day for 5 days. And the dot plot shows his data. So one day he read 25, another he read 28, 32, 36, 42. Is 30 pages a good estimate of the mean number of pages that Han read each day? So 30 would be right about here. And I don't know. I feel like it might be a little higher than that because you have a 42 up here, which is really going to bring you up. I mean, you got two numbers on the left of it and three numbers on the right. So I feel that's a bit low. I feel that's a bit low. Doesn't seem like the center. That's what I'm going to say for my reasoning. It doesn't seem like the center. The center seems more, maybe around 32, 33 would be my guess. I don't know. Find the mean. Okay, we're going to find out, I guess. Find the mean number of pages that Han read during the 5 days. Draw a triangle to mark the mean on the dot plot. I guess I probably need to delete the estimation because we're about to find the real deal, and that might change things. Of course, my erasing tool is not working correctly. It's acting really weird. Let's go bigger. Make it bigger. That didn't work. Okay. Whatever. I'm not wasting time trying to erase a triangle. We'll just draw a new one when we get there. So the mean. So let's add them all up and divide by how many there are. So we got to add the numbers here. We got 25, and we're adding 28 to that. We're adding 32 to that, 36 to that, and 42. So we got all these numbers. Let's add them up. That makes 10 plus 5 is 15, 17, 23. So 3, carry my 2. Let's add all these up. 2, 4, 6, 10, 13, 16. So 163. And then we're going to take that total and divide by how many there are, which is 5, 3 times. Subtract 1, 13 goes into that twice with 3 left over. So 3 left over would give me 3/5. 32 and 3/5 are 32.6 is the actual. So I'm going to use a blue triangle for this. 32.6. Here's 33. So right about in here is where the mean is. So my estimation over here was right. It should be a little bit higher. It should be centered around the dots, not kind of leaning toward one side or the other. So we drew the triangle mark there. It's at 32.6. Use the dot plot and the mean to complete the table. All right. So let's go back. And let me double check my addition there. I feel like maybe that should come out a whole number for this example. I could be wrong. 36, 32, 25, 28, and 42. You get all the numbers in there. No, 163 is what I'm getting there. All right, so use the dot plot and the mean to complete the table. So the mean is 32.6. So 32.6. And I got to find out how far each of these pages are from that. So I got to subtract all of these numbers from 32.6 and find out how far they are away. Okay, so when I write these numbers down, I'm going to use my calculator to do that I have in my hand, just to kind of speed it up a little bit. So I'm doing 32.6 minus 25. That's where my 7.6 is coming from, okay, because I'm subtracting this number by all of these. Okay, 32.6 minus 28, that gives me 4.6, right? 32.6 minus 32, I don't even type that one in. That's just going to be 0.6. And now that I've transitioned to numbers that are bigger than 32.6, I'm going to type the bigger number in first because it's a distance and I'm not going to get negatives here. So I'm going to change to 0.4s here on this one, 3.4, and then 42 minus 32.6, which is 9.4. Okay, and where was it of the mean? This one was left. This one was left. And whenever we started to transition to the bigger numbers, they were to the right over here on the other side of the mean. So they were on the right side of the mean. That's pretty simple there. And then it wants us to calculate the mean absolute deviation, which means I'm going to add 7.6, 4.6, 0.6, 3.4, and 9.4. We're going to add them all together, and then we're going to divide it by how many there are. 1, 2, 3, 4, 5. So we divide it by 5. All right, so let's do that. 7.6 plus 4.6 plus 0.6 plus 3.4 plus 9.4. That comes out to be 25.6. And we're going to divide that by 5. And that gives us 5.12. So I've got a MAD of 5.12 for this particular problem. And that kind of tells me my variability. It's fairly big because the numbers were pretty spread out. There wasn't any compact there. They were all fairly far away from the number in the center there. So 5.12. All right, let's look at number 2 here. We've got 10 sixth grade students recorded the amounts of time each took to travel to school. The dot plot shows their travel times. It's already found the mean for us. It's 9, so that's nice. And then it has the MAD is about 4.2. Which number of minutes is a typical amount of time for the 10 sixth grade students to travel to school? 9 or 4.2? 4.2 is a MAD. 4.2 is not a number that would be in this data set. The mean is a number that would actually kind of be in the middle, the average. So that's the number that makes sense here. So 9, okay, the mean is an average time. So we're going to choose the mean on that one. Based on the mean and MAD, Jada believes that travel times between 5 and 13 minutes are common for this group. Do you agree? So 5 and 13. Let's see what she did here. I guess it looks like she just took the 9 and went 4 down and 4 above. And since the average distance away from the mean is 4.2, that would make sense. I agree. The average distance from mean is 4. About 4. Is about 4. And, 9 plus 4, you could say like 9 plus 4 equals 13. And 9 minus 4 is 5. So it makes sense that it would be between those two numbers. The average distance is 4. A different group of 10 sixth grade students also recorded their travel times to their school. And their mean travel time was also 9, but the MAD was about 7. What could the dot plot of this second data set be? Describe or draw how it might look. Okay, well, my guess, since their average was the same, the dots are going to be centered around 9, right? So the dots would be centered around 9, which is, we'll put 9 here. But since I'm going to put this as 0, and this as, I guess we'll do this as 18 just to kind of get an idea. We're 9 away. Okay. Their average distance away is 7. So we're probably going to have dots around 9, but not as tall, probably. And my guess is it would be more spread out. Maybe look something like this, right? It's not going to be as stacked like this one is and compact, but it's going to be more spread out. There might even be some kids that are going, here's 27. There might even be some kids that are taking longer times, right? Maybe you got a compact over here, but it's all going to average out to 9, but spread out more, right? It says we could draw, so I think it'd just be spread out more, not as tall, not as compact as this one. And I know that because the MAD was bigger, okay? Bigger MAD means more spread. So we'll just have more variability, more stretching here. And that's it. That's your homework for this week.